Hello friends, in this part on cubes and dices, what we'll be discussing is that if a pattern in this way is given to you, so the unfolded portion or the unfolded pattern of the cube, if I do fold it, what cube am I going to get? That is the questions we're going to be looking at. Now firstly, in the part 2 video also I explained to you, let me just revise that little bit. Let me number these faces 1, 2, 3, 4, 5 and 6. You need to remember that 1 is opposite to 3, that is this. 2 is opposite to 4 and 5 is opposite to 6. So the alternate faces are opposite, and the flanks are the top and bottom ones no matter where they are. So even if you have one here and one here, they will still be opposite to each other. So that is the first concept you need to remember. Secondly, when I fold this thing, let me just erase this. When I fold this thing, this edge actually goes and joins here. So you can just try to remember this, and this edge goes and joins here. So the near edge goes and joins the near edge, and the far edge goes and joins the far edge. If you actually fold it, you will see that this is true, and similar is the case with the bottom ones. This edge goes and joins here, and this edge goes and joins here. Why this is important is that in certain cases, some of these might have symbols which would touch these edges. So I might have, let us say, here I have a triangle which is colored like this. So, and here I have a certain, let us say, square at this edge. So I know that this thing is going to touch this thing. It may help me in eliminating certain choices. This you just remember. I will, so you can try to use this in certain questions. Now I'll be taking two very simple examples here. Okay, firstly, the question is, this is the pattern that is given to me. Which cube will be formed if I fold this? So now let me start simply. Let me take this. In this case, I told you that from here I know that F is opposite to B because they are alternate. So if F is opposite to B, I cannot see them in the same face. So this means this view is wrong, because F would be, if F is here, B would have been, B should be the bottom face because they are opposite to each other. So this is eliminated. Similarly, here I have FED. So okay, here I can't say because F touches E is fine, E would touch D is fine. Let me leave this for the moment. Let me go here. Here I have again E and C. As you can see from here, E and C are again opposite because they are alternative to each other. So E and C, because they are alternate to each other, cannot be seen in the same view. So this is again eliminated. Then let me go to this. This is D and A in the same view, but I told you the flanks are always opposite to each other. So A is opposite to D. As I told you, from here I got E is opposite to C, because so this is wrong. Here again this is wrong. So this is my correct answer choice. As I told you in the part 2 of the video also, in a cube, each face touches each other face. So this face is going to touch all the other faces of the cube except the one which is opposite to it. So this concept clubbed with this basically you can use to find out a lot of questions. Let's look at this question again. Similar question. Here we can see that in this case, this and this, the flanks are opposite to each other, but in this view you can see this triangle and this diamond here. So this cannot be true, and you can see this here as well. So this is also not true. So two choices I have eliminated. So now I am left with these two answer choices. So what I can do now is something simple here. If you see this, let me just draw this here. This is a triangle and this is the cross. The square of the cross, so this whole face here shares an edge with the triangle here. Okay, so this is the edge that they share. So even after folding, they should share an edge. right? This you can understand if you can just, if you can't visualize it, just take a piece of paper and do it. Just draw this and fold it along this line. So even after you fold it, this triangle's edge should be common with the edge of the square, this square's edge. Now if you see here, in this case, this is the edge of the triangle and this square has a common edge. But in this case, I have this as an edge of this triangle and I have this as the edge of the triangle, but the square which contains the cross does not share an edge with the triangle. So in this case, so let me just draw this bigger for you. This is the square and this is the triangle. The two edges of the triangle, the side edges, are basically this one and this one, but they do not share an edge with the square containing the cross. So this is not the right answer and this is the right answer.